Okay, in this video we're going to talk about how to use segments and lines that intersect in and around circles to solve for missing segment lengths and angle measures. Let's start off with a definition of a secant line. So a secant is a line that intersects a circle at 2 points. So in this diagram we've got line AB, which is an example of a secant line. We can also have a secant ray, so ray AB would be a secant ray, and we can also have a secant segment, so segment AB is a secant segment. Now notice that they call that a secant segment and not a chord. So a secant segment contains a chord, but a chord would have to have endpoints on the circle itself. So the chord, if we highlight that there, that would be our chord, which is contained in a secant segment. Okay. Angles formed by secants, tangents, and chords intercept arcs on circles, and the measures of the intercepted arcs can help us find measures of the angles. So let's look at our first theorem. Theorem 1111 says the measure of an angle formed by two lines that intersect inside a circle, I'm going to underline that, inside a circle, is half the sum of the measures of the intercepted arcs. Okay, so looking at our diagram here, on the right here, we've got two secant lines that intersect inside the circle, and notice that they cut off two arcs here. We've got one arc here in yellow, and we've got the other arc here in blue. Alright, so looking back at our theorem, this says that the measure of angle 1, and I might just highlight this formula here, pretty important, that the measure of that angle 1 there is equal to half the sum of those two arcs. Alright, this works whenever we got an intersection inside a circle. So let's give us some numbers. Let's say that arc X is 80 degrees. And let's say that arc Y is 30 degrees. And we want to find the measure of angle 1. Okay, so using our formula, we've got the measure of angle 1 is 1/2 the sum of these two. Since we intersect inside the circle, we're going to take the sum. So 80 plus 30. 80 plus 30 is 110. So we want half of 110. Half of 110 is 55. So the measure of angle 1 is 55, and that's in degrees. Okay, so that's our measure of angle 1 right here. And then notice since we've got two lines that intersect, we've got a pair of vertical angles. So that second angle in orange there would also be 55 degrees. Okay, what if the intersection is outside the circle? Okay, so part 2 of that theorem says the measure of an angle formed by two lines that intersect outside a circle. Okay, so I'm going to underline outside a circle is half the difference, underline difference, of the measures of the intercepted arcs. Okay, so these two formulas are a lot alike, but they've got these two differences here, so it's important to pick those out and to compare these two. So if our intersection is outside the circle, we're going to take the difference of the measures of the arcs and cut that in half. So let's look at three different situations, three different possibilities of how this might happen. Okay, this first circle here. We've got two secant lines, or secant rays, that intersect outside of our circle. Okay, notice the intersection point out here. So instead of adding the two arcs and dividing by 2, we're going to subtract the smaller from the larger and divide by 2. Okay, so let's give it some angle measurements. What if we give it the same ones we just had? What if this is an 80-degree arc? And what if Y was a 30-degree arc? Okay, so we want to find the measure of angle 1. So let's say, come over here, the measure of angle 1 Since the intersection is outside, I want to do the difference of the two. Make sure you do the bigger arc minus the smaller arc. Alright, so 80 minus 30 is 50, and half of 50 is 25. So the measure of angle 1 is 25 degrees. Alright, let's look at another example. Situation of how two lines can intersect outside a circle. So in this case, we've got a secant ray, and then we've got a tangent ray. So notice the one on top touches the circle in exactly that one point there, but the secant ray touches in these 2 points. Okay, so we want to do the same thing. This time we've just got an arc formed over here, and then we've got our smaller, our minor arc here. Okay, but we've set it up, same formula, 1/2 the difference of the arcs. And our third scenario is when we have 2 tangent rays or lines or segments. And so we've got our angle 1 here, and we want to find the measure of that angle. To do so, we can find the measure of this arc. So remember, we've got a tangent point here and a point of tangency here. So we take the larger arc, which is this large X here, and we want to subtract the smaller arc, and we want to take half of that difference. Okay, so same formula, just 3 different scenarios. Okay, so let's look at some examples. Actually, how about pause the video, and I want you to try these 2 examples here. Alright, so let's look at these 2. So, first one, find the value of each variable. We've got an x, which is the measure of this angle in degrees, right here. And we've got these 2 arcs that are intercepted by those intersecting chords. So, to find the measure of that angle, which is x, so x is our angle, that's going to be 1/2 the sum of our 2 arcs. So we've got our larger arc and our smaller arc here. So we've got 90 plus 46. Okay, so that's 136. So I want 1/2 of 136, which is 68 degrees. So the measure of that x is 68 degrees. Alright, moving on to the next example. Let's see if we got this one right. So now we've got an intersection outside the circle. So instead of adding our 2 arcs and dividing by 2 or cutting it in half, we're going to subtract. So let's find our bigger arc here. That's 95 degrees. And our smaller arc here is x. So we don't know what that arc is. So this one's going to be a little different. We're going to set up our equation the same way, but we're going to be solving for a different variable. Okay, so our angle measure, this time we know our angle measure, which is 20, is equal to 1/2 the difference of our 2 arcs, since our intersection's outside. So our larger arc, 95, minus the x. Okay, so now our goal is to solve for our variable, so we want to solve for that x. So the first thing that I want to do is I want to get rid of that 1/2 in front of my binomial there. So I'm going to multiply both sides by 2. Oops. Multiply both sides by 2. See if I can fit in a 2 here, times 2. Okay, so that's going to give me 40 on the left, and 1/2 of 2 is 1, so I'm left with just 95 minus x on the right. Subtracting 95 from both sides, I get negative 55 is negative x. But I don't want negative x, I want positive x. So multiplying both sides by negative 1, x equals a positive 55 degrees. Alright, so this is the measure of that arc there in blue.